Our last keynote speaker for today. We're going to go from a discussion on international pilots to someone involved with, well, shall we say, intergalactic pilots. Our next speaker is Dr. Jaiwon Shin, the Associate Administrator for the Aeronautics Research Mission Directorate at NASA headquarters here in Washington, D.C. Dr. Shin has more than 15 years of experience at NASA. He's been in his position since 2008, and prior to that, he served as the Director of Aeronautics Projects Office at NASA's Glenn Research Center. And our ALPA Director of Engineering Air Safety, Keith Hagee, will like this. He also got his doctorate at Virginia Tech in Blacksburg. So, NASA research plays a key role in ensuring that a safe airspace system is maintained and improved upon as new ideas take form. Sounds like a familiar theme, and that's common ground for us here at the Airline Pilots Association. In fact, it's the very mission of the ALPA safety structure. Today, he'll tell us about NASA's aeronautics vision and strategy. He'll share how NASA keeps safety as its top priority as it moves forward. And he'll divulge several new concepts for us to discuss, including NASA's aeronautics, new strategy and implementation approach, important global trends in our business, recent accomplishments in ATM, safety, and vehicle technology development, and finally, current research for some future projects. I'm extremely excited to hear his speech, so without further ado, please welcome Dr. Shin.
Great. Thanks for that kind introduction. The clock hasn't started, so that's great. But it's a great honor, and I'm really pleased to be here, and thanks for the invitation. And I know it's getting late. It's 5 o'clock. If you guys want to stretch your arms and legs, this would be a good time to do that. When you're on a long international flight, sometimes airlines put that video for some exercise, right? Sitting in the seat. I think I have about half an hour, and I know you have a reception to go, so I tried to keep my talk in half an hour. But what I would like to share, okay, there's a clicker. What I'd like to share with you for next half an hour or so is really where NASA Aeronautics has been, but not so much in the past, but where we are trying to head out for next 100 years. So that's why the title of my talk is NASA Aeronautics for the 21st Century. And this past March, we actually celebrated 100th anniversary of NACA, the establishment of NACA. For this crowd, I don't need to explain what NACA is and was, and how critical the establishment of NACA was for our community. And in 1958, that was merged into NASA. And so we are now part of NASA as the federal agency. In aeronautics, that was the whole of NACA during the first half of the last century, is the area that I'm responsible for now. So you can see the last panel talked a lot about safety, and our 3 pillars in aeronautics research have always been safety, efficiency, and the performance. So we work in vehicle technologies for efficiency and performance, and also work in air traffic management area for certainly efficiency, safety, and safety as also another pillar. So if you ask me what the perspective of aviation safety, safety should be everywhere, not just separated from vehicle or ATM. And I actually grew up in aviation safety area when we formed aviation safety program back in early 2000, and some of you, I'm sure, had involvement in that. I was part of that aviation safety program at NASA. So a lot of accomplishments that you can see that we are proud of. We accomplish all this together, not just NASA alone, certainly, and as our Boeing friends would probably tell you in private, they told me in private setting that NASA technologies are DNA of their airplanes. So I think that is not an exaggeration, and that is the actually testament of how we all work together to accomplish this amazing feat. Again, I don't need to go through this. Sometimes this is useful when I go to a Hill and talk to congressional staffers and members on the Hill, because they don't sometimes appreciate how important aviation is for this country. And the $78 billion trade surplus, that's very rare. That is actually the highest level of trade surplus that aviation industry brings to our country. And there are only very handful of industrial sectors anymore that have a positive contribution to our trade. So when I look at you, ALPA, you are at the forefront of this. Whether you are captains of passenger airplanes or cargo airplanes, you are really the backbone of this amazing feat, and also the critical transportation system for our country. And so it is really grateful that I work in this area, and if the NASA's role in all this, in this enterprise, if you will, is really enabling our customers and stakeholders to do better and bigger and faster and all those things more efficiently. So we are the technology people, and we work very closely with FAA and other government agencies, and also industry and association like ALPA and others. So I want to share a few things about what's happening around us, because we are number one in the world. I say that without any hesitation. I think in terms of technology and the system and safety and efficiency, when you think about all that, really other countries just envious of what we have accomplished. But things are changing around the world. And again, for this crowd, this will be just a reminder. There isn't anything new that you didn't know when I talk about the global trend. But I think it is important for us to remind ourselves that the global landscape is changing. So for those of you who fly to Asia Pacific region, you probably see already that phenomenon, that the air traffic growth, whether you count by number of passengers or number of flights or revenue generation, no matter what metrics you use, I think you would come to the same conclusion that the traffic growth is moving to Asia Pacific region. For the last 5 years, this is IATA data. Last 5 years, China alone has been adding close to 200 million new passengers, additional passengers. So that's about a quarter of the entire global forecast for new passengers. So both Boeing and Airbus have done their market forecast, and that's what on the right-hand side of the chart. And by 2030, these numbers very close between Boeing and Airbus. And by 2030, industry thinks that there needs to be about 33,000 new airplanes. So that's really good news for all of us. It's rapidly growing industry, and that the money tied into that is about $4 to $5 trillion just for hardware. Again, it's Boeing estimate. And by the time you add service and parts to that hardware sales, that's another $4 trillion. So you're really talking $8 to $10 trillion market in the next 15 years or so, if you believe Boeing and Airbus projection. So even if you discount that, the rosy picture, by 30%, that's still a lot of airplanes. And those are new aircraft, by the way, not the refurbishing or doing anything to extend the aircraft life. So that's an important trend that I think we all need to watch. But there's another trend that has nothing to do with aviation and also a technology aspect of it. But this huge shift in population centers to metropolitan areas is really accelerating. So by 2030, the data shows, or projection shows, that about 70% of world population will live in some kind of metropolitan areas. So there will be probably 20, 30 mega cities. It's not even cities, it's probably almost close to small countries in terms of number of population scattered around the world. What's the implication of that? How would you connect those mega metropolitan areas? I think the answer is pretty obvious. So that is important trend. Another trend, as a technical, let me see if I can borrow the water here. As a technical weenie, this is the very interesting and encouraging trend that I like to see. That is the introduction and adoption of new technology is rapidly accelerating as well. So the way you look at the chart is, if you look at the electricity at the bottom, it took 46 years for the 25% of US population benefited from that new technology, starting back in 1873 or around that time. So it took a long time for 25% of our population benefited from that technology. And you can guess easily why that took that long. It's not the people who were lazy back then. It's just you need a lot of infrastructure, and we're a vast country, so it took a long time to do that. Versus at the very top, World Wide Web, the internet, took only 7 years. And when I look at this data, I thought, really? I thought it took only 2 years. But regardless, it's accelerating. And a lot of advances from IT area, IT world is starting to dominate these technology advances. And so some of the automakers told me that they consider their new automobiles as just shell, a housing bundle of software. So the new S-Class Mercedes-Benz has more lines of computer code than F-35, if you can believe that. So that's what's happening around us, and aviation is not going to be immune to that technology trend. So those were the backgrounds that why NASA Aeronautics really studied global socioeconomic, geopolitical, technology, certainly technical trends for past 2-3 years. And then we developed a new strategy to support U.S. industry. When I say industry, I'm not talking about only manufacturers, but carriers as well, and all the subsystem providers. So as a whole, U.S. aviation industry, how can we better support, enable the U.S. industry to stay at the top of the game? So 6 strategic thrust areas, as we call them. You can call them our research focus for next, certainly, decade, but hopefully this will actually be valid for next couple of decades, and we are trying to set the groundwork for next 100 years of excellence, as NACA has enjoyed. NACA plus NASA have enjoyed last 100 years of technical excellence. So in the interest of time, I'm not going to go through all that, but for this community, a few things that you would see very interesting or taking a great interest is the first one, the safe, efficient growth in global operation. That's the code word for safe and efficient air traffic management. So our carriers, all of you, and many of you fly to foreign countries. And last November, I was in China for the first time because we had some kind of moratorium not to have any bilateral discussions with Chinese government. That's the that's the law for us. But case by case, we were able to have this bilateral discussion, and we thought ATM area is very important for us to start having some working relationship with Chinese. So I was there in Beijing, and I was sitting in an airplane for 2 hours heading to southern part of China, or scheduled to head down to southern part of China, but for 2 hours there was no announcement of any kind. We're just sitting there, and fellow Chinese passengers seemed very comfortable. No one was visiting, and they were all kind of minding their own business. And myself and my delegation were all visited and said, what's going on for 2 hours? And it took off, but it's still no announcement or nothing. And so later, during the stay, we had a meeting with American Chamber of AmCham there in Beijing, and there's actually FAA embed working there. So I mentioned this and talked about that, and he said, in China at the moment, there is no concept of efficiency. They don't even know how much capacity they have. So efficiency is not in the equation as yet. So some of you flying to China, I think probably resonate with this problem. That we are, our carriers, I heard, losing a lot of money operating in China because of this kind of inefficient operation. So our carriers fly to all around the world, and our citizens fly to all around the world. So ATM, safe, efficient ATM is really for the global operation. We can't isolate only just looking at Kanos here. So that, I think that you probably see a lot of interest in there. And then ultra-efficient commercial vehicles, that's actually our bread and butter, that we have always been working in this area, whether it's airframe technologies or engine technologies, avionics, all those related to air vehicles. We have been working very heavily, and we will be working very diligently there as well. And real-time system-wide safety assurance there. Again, the last panel talked about amply of the safety and security, system-wide data sharing. Actually, the SIOS that was discussed, and the data mining technologies and data analytic technologies were actually provided by us from NASA to FAA. So we're very glad OSIOS is really helping the community. So those are just some representative description of these 6 areas. But again, in the interest of time, let me switch to some specific examples of what NASA Aeronautics has been working on and transferring our technologies to either manufacturers or FAA and other user communities. So this one is just really one example. In the last 3 years or so, we have transferred 5 major algorithms to FAA. This is one of them. Precision departure release capability in order to maximize the capturing the en route slot once you take off. That is the algorithm that we have developed, and we did a trial test, and as you can see, we were recovering, what does it say, more than 50% from the baseline. So when we transferred this technology, my counterpart at FAA actually had an interesting analogy, and I didn't know he was a car guy, but he said to him, what this means is when he wants to go home from Washington office and get on 395 or I-66, whatever the highways that we have in this town, he would know exactly when to leave his office in order to get on I-66 behind red Corvette and in front of 18-wheelers. So this algorithm will tell you what time you have to get out of your office and start driving. So I think that's a fairly accurate analogy. So that is the kind of decision aid support and automation and optimization that we have been working on to support this community and airline industry. So again, that's just one example. I'm sure you take great interest in this advancement in flight deck because that's where your office is. And I want to make sure that, let me just go ahead and click this. I want to make sure that I portray some of the activities that NASA is interested in to this community accurately. So you probably have been hearing that NASA started looking into a single pilot operation or reduced crew operation. I'm not a technical guy in this area at all, so I'm pushing papers at the moment, but but I can direct our technical people to be on the right path. And I think it's not just me saying, but our researchers are absolutely concerned about the safety, and this is really trying to address the safety for most. You may hear that this is to bring efficiency up or saving the cost. All those are secondary and tertiary benefits, I think. And the safety is really the reason why some of the NASA technical people have been looking into this. So without getting into, again, a lot of details there, I think you can see that from 5 crew cockpit to now 2 crew cockpit. While we are advancing that way, we didn't compromise the safety. So this is an amazing feat, actually, if you think about it. And what enabled that maintaining and actually even not just maintaining, but improving safety levels while we were reducing number of crew in the cockpit. the left-hand side some of the examples of technologies. So technologies keep coming in, and right now there's a fashionable term in technology and R&D world as well, that is autonomous systems. So increasingly autonomous systems. So some people may take a misinterpretation, thinking that the robots or the machines will take over or the cockpit operation or anything like that. I think that's the furthest from the truth. That the research topic really is how to understand the human and machine interactions and what would be the human's proper role in these increasingly autonomous systems that we are facing. I think that phenomenon and that trend is inevitable. More and more autonomous systems will be introduced and come into the system. So how do we make sure that safety is ensured, but at the same time, human role is clearly defined and harmoniously working with the autonomous systems. So that's kind of our perspective in this. It's, I think, part of evolution in advancement in the flight deck. Switching the gear a little bit, talking about the performance and efficiency, and we've been working heavily to reduce the emissions and reduce the fuel consumption and also reduce the noise level. And this is really to sustain the entire aviation enterprise. So we are at the moment, I think this is accepted by science community, that the entire aviation, commercial aviation contribution to global CO2 deposit is about 2%, 2 to 3%. That's what scientists have been saying. So it's minuscule if you really think about it. But it's highly visible, and we are depositing CO2 in the wrong place, in the wrong altitude. So I think that's why a lot of governments are paying special attention to aviation. So reducing emission and noise is really for the sustainment of this aviation enterprise. And so we've been working on various technologies, airframes and propulsion technologies. And by 2050, if industry actually implements all this collection of technologies, we can project that some 80 billion gallons of fuel can be saved. So some huge numbers. And we're also working on some new configurations. I think I'm getting a cue to wrap up here. Okay, so we're working on new configurations as well. As I said, NASA is enabler. We do research, and we don't build any airplanes, any engines. We are not implementers. We are not regulatory agencies. We develop future generation technologies and making sure when our manufacturers and operators are ready, those technologies will be available. So the name of the game for vehicle technology is, of course, reduce drag and increase lift and reduce the fuel consumption. So a couple of ideas there. They are not the only ideas that we are thinking of, but just two examples there. And so we are doing wind tunnel testing and hoping to do actual flight test with some of these configurations. We're going even further. This is an emerging area, so we are not really investing heavy here as yet, but eventually things will become more electric. And so the concept there is you have two gas turbine engines at the wingtip, but those two gas turbine engines are not for propulsion or thrust. They are to generate the power to drive electric motors. And then those electric motors will drive fans, distributed fans. So you essentially increase bypass ratio to infinity, so in theory. So the efficiency, propulsive efficiency will go way up, and the emission will be reduced substantially, like 90%. And also noise reduction will be there. So how soon can we get there? Who knows? Maybe 30 years, 40 years, but we need to start working on that. Let me just talk a little bit about UAS, because I know you guys are quite interested in this as well. We believe we have worked on this for years, but we believe that UAS should be integrated into NAS as if there's no difference, that we cannot have a separate rules and dedicated rules for only UAS. It's a one NAS. So how do you integrate UAS into the same altitude that our airlines fly? And how do you make the UAS being treated same as manned aircraft? So that's what NASA has been working on for the past 5 years as a focus project. We've been investing about $30 million per year to conduct this research, heavily working with FAA and RTCA. And our role is developing database, knowledge, tools for RTCA to set the minimal operation standard, so that FAA can start making informed decisions for rules. So that's kind of, if I can use that regular altitude, I know there is no term like that, but regular NAS. There's another issue, right? That these Amazon and Google types, those companies are interested in flying this small UAS at a very low altitude, like below 500 foot. So this is also coming. If we don't work on this issue, there will be Wild West out there, and it's going to create all kinds of issues and problems. So we began working with the community. This time it's a very different community. Again, it's Verizon, Airware, Amazon, and all these very different non-aerospace companies. And they have very different level of expectation for timeline and the way they are thinking. So we are also learning how to work with these new partners. But it's a really complex issue. And what we are trying to do is help, again, community and FAA setting up the rule of the roads, if you will, that you have to start putting the informed database, so that, again, regulatory agencies and the whole community, this emerging community, can deal with the demand. So while it's very exciting, it's also bringing many different types of new challenges. So stay tuned. And again, our goal is utmostly for safety. And we don't want this community to lag behind foreign countries, but at the same time, we certainly don't want to compromise safety. So this is kind of our commercial, what we have contributed to help all of you in aviation industry in general. So I don't need to go through all that. But I'm very thankful to ALPA because a lot of research that we conduct, whether it's a human factor research or ATM research, in some even performance areas, ALPA has been providing valuable advices and also pilots to work with us to test our ideas and tools and method. So it's been a really good partnership, and we are hoping to continue to evolve and improve our partner. And he is my former boss sitting there, And so I have a direct connection to ALPA. And my former colleague also sitting back there, John White. So with Lori and John being in ALPA and many other partnership that we have been enjoying, thank you very much for advancing all the technologies that we need for the community. So thank you for your support and thank you for your time.
Thank you, Dr. Shin. That was just an incredibly interesting presentation, and I hope you'll consider coming back once again and joining us one more time. And also, I wanted to invite you, we're going to have a reception outside. It's hosted by Boeing, and I'd like you to join us if you would. Thank you very much.
Thank you.
Thank you.